Here. So, hello everyone. You're at track 2 for Modern Pentest Tricks. You're at the right show. I'm Thomas. I'm pretty excited. It's my first time at Area 41, my first time in the rig, so thank you. Thank you for being here with me. As I said, I'm Thomas Debize. I'm just an InfoSec. I used to be an InfoSec auditor and incident responder. And you can check, I like to push some tools on my GitHub. If you ever tried or used one of my tools, just say hello. That would be cool. Thank you. So the agenda for today, I will just give you a bit of context, my analysis of the last decade for penetration testing and security tools, open source mostly. Then we'll dig into the core and the essence of this topic and for modern tricks. And taking a step back, that won't be long. So what really changed during that decade? In 2018, it's now possible, it's now easily possible to first scan the entire IPv4 space in minutes/hours/days, depending on your connections and how much throughput you want to put into. First, with distributed vulnerable computing, with the census, one of the first whole IPv4 mapping stuff. It's a bit old, but that was the starting of everything. Then you have the asynchronous programming. I'm sure you know ZMap, mass scan, unicorn scan to perform large and wide scan on the internet. And then if you are too lazy to perform your own scan, you can request some data from third-party platforms such as Shodan. I'm sure you know Shodan. Zoomai. Who in this room ever heard about Zoomai? Not that much. Zoomai is the Chinese Shodan. Less restriction. I don't even know if they have a paid plan and good data, good data quality on this. You have scans.io giving you a lot of whole IPv4 scans from different providers, different universities, different projects. Then you also have the census.io, which is a private-owned stuff, giving access to some dataset, huge dataset. Then now you can easily query all those information you want offline, building your own platform. I don't know if you ever heard about this talk, but it was shown last year at Debize Las Vegas. It was really awesome. Just to someone, Faidom6, just describing how he built an entire OSINT platform for free with open source stuff and on your own hardware. Then, if the offline aspect is not that important for you, you can still request some online stuff with the ReconNG program. Who in this room ever heard or used about ReconNG? Right, this is an awesome tool really to query a lot of different sources for OSINT information, cartography data, credentials, locations. It queries, it has modules for everything. You have the domain tools. Domain tools is a pretty famous third-party paid platform. It's not that cheap, but good quality data and one of the oldest platform for this kind of usage. Passbin, which is a true source of information for everything again. Certificate transparency, giving you a lot of insight about a company or a project, certificates, host names, virtual host, and so on. And then now it's easy to pull large Windows corporate infrastructures with awesome tools. And some people showed and talked about some tools just before for Red Team from the trenches talk and so. So you have PowerView, Blowdown. You have CrackMapExec, an awesome tool. Responder also for man-in-the-middle stuff. Post-exploitation, Mimikatz by a French guy. Did I say I'm French, so just a warning, please excuse my bad English, I'm French. Invoke Mimikatz, which is the StealthC version and PowerShell version of Mimikatz, Empire and its agents, or everything inside one tool, Destar. So the landscape totally changed during that decade, and what was quite impossible to imagine before, it's now feasible, and you have to do it. And that's the next slide. Why do you need to adapt do you need to adapt your techniques, your current techniques, what you already and always used? Because more and more security faults are writing more tools. Because more and more security faults, again, are writing good quality software, which is quite new, to be frank. If you remember Netcat, the first version of Netcat, NCAT, sorry, not Netcat, which is the modern reimplementation of NCAT, but NCAT for years had a buffer overflow vulnerability inside, and every attacker used this. Now, good quality software is the key. Because you will be asked as practitioner, security practitioner, either your penetration tester, incident responder, you will be asked to cover wide and wide scopes. And because, to be frank, it already has changed. Current penetration testers are already asked to scale. Just from what I know and from my personal stuff, a few months ago, I was asked to perform some penetration tests on a large Windows domain having like hundreds of thousands of people, objects, and assets. It was wide and wild. So it is right now. You have to change. You have to adapt your methods. You cannot stick to your tiny domains, tiny Windows domain or OSINT recognition stuff. You really have to adapt and to scale right now. So the first point to scale is to use a proper data format. So as you know, I don't know if I teach you this thing, but pentesting involves a lot of iterative work. You scan some stuff, you exploit, you harvest some new data, and you apply it on new and old data. And that's it. That's the wheel. Our job is a wheel, is an advancing and a leading wheel, but that's why you need to process a lot of data every time during multiple phases of an engagement, and you need a really good data format. So what comes in mind with data format is CSV. CSV is a simple format, a common format. Every programming language has its version, and just use it. There's a lot of things, and it is a human readable format. So hello XML, but you're not allowed in this room anymore. And this is a simple format, but there's no standard for CSV. Everyone can produce his own CSV. Doesn't mean anything. CSV it's just stating that you're separating some stuff with another stuff. So you can encode it however you want. Coding and escaping, please escape whole fields every time not to be able to prevent any mistake and to unwanted stuff, because at some point you will have some broken stuff because you don't code data and code field inside. So, and one last thing, just beware of CSV injection. It's a true attack, and it's a common and simple stuff to put some people through Excel spreadsheet and so. But CSV, and always CSV. I will just on this slide show you some common penetration testing and security tools offering CSV output, and even better, trying to process CSV input. First, you have Nmap to CSV that I developed just to convert an Nmap output to a CSV. For large, when you have hundreds and thousands of targets, you cannot really read a standard Nmap output. You really need a tabular stuff, like a database stuff. CSV is a database. You will see it just after. Then you have WFuzz, a good replacement for Dearbuster, DRB, and whatever you always used. TestSSL.sh, Bloodhound to find some compromise paths of crack. ReconNG, I talked about it just before. Nikto, which was and still a good web server, scanner, and fuzzer. And they adapt, the tool is quite evolved, and it's not the same script as 10 years ago. And finally, Nessus. It's really useful when you perform a large vulnerability scan, not for red team stuff, because when you're red team some stuff, you don't use Nessus. But when you're on the compliance and the defensive side, you use Nessus, and you need a good view of your asset vulnerability. Shortly, how to handle CSV, because using it is good, having appropriate tools to handle it is better. First, Microsoft Excel. And here right now you say I'm not in this talk just to hear about Microsoft Excel, but Excel is a good software to process and handle a tiny CSV file with the text to column, and then you can choose your delimiter here. But the main problem with Excel, and this is a current and a common issue, the max number of lines for Excel is 1 million. This is nothing. This is not big data. 1 million is like tens of you take an Excel file of 10, 20, 30 megas. It's way more than 1 million rows. So you cannot open it with Excel, and this is a common encounter issue. Then better, and one of the best tool suite you can use for CSV is CSV Kit. So CSV Kit is a suite of command line tools for converting and working with CSV. For input stuff, when the input phase, CSV clean, CSV format, just to correct and ensure you have the proper format inside and you can convert anything to CSV. Processing, so here you will see your common Unix utilities, so cut, grep, join, sort, stack, but adapt to CSV. So not talking about line, but talking about field right now. So a line has different field, and you can have the same process you had for lines before, but for a specific field. That's really, but that's to be frank, that's a bit funny, but it quite changed my life a few years ago for engagements. Let's take the CSV grep. The things you can see in red, I think the thing I use the most, but every utility is really awesome in this suite. CSV grep, you can have the grep, but just for one column, and except of piping your old-fashioned way to process data, so hawk, set, cut, grep, and whatever. With grep, you can do CSV grep, you can do a grep, but for a specific field. Join is really awesome, CSV join. Execute a SQL-like join to merge CSV file on the specified columns. Oh, there's a typo here. It's on a specified column or column. There, oh no, this is not a typo. You can perform a true SQL query. Your CSV is a database, and you can treat it as a database and perform whatever SQL and SQL treatment processing you want. This is really awesome. It doesn't look like, but it is. CSV sort, CSV stack, and for the output, CSV SQL, perform a standard SQL. For join, you can join multiple CSV files. For CSV SQL, you just can perform any SQL request you want. CSV stat, I will just show it to you just after. It's really awesome to have some statistic per field. How to install it? It's really easy. Pip install CSV Kit, nothing else. So demo time. So in this, I have a lot of demos for this presentation. The first I want to show you is how you can have some cool information without touching anything. So in the folder I hope everyone can see. I do have, let me check. I just have two CSV files. One is quite tiny and the other one is a bit bigger, but nothing really interesting. Inside this is only a Nessus output filter on MS, Microsoft KB, and Microsoft unpatched stuff. So without touching anything, if you use CSV stat, I hope we'll be able to see a lot of stuff. But I'm just using it without touching even the CSV, and I will have some statistics per field. So not all the statistics are relevant. And the bottom stuff is really not interesting. But first, so in your Nessus output, you have different columns. The first is plugin ID. Here, if you want to perform some mathematical stuff, you have the most common stuff. You can see this is interpreted as a mathematical and numerical value, but this is a plugin ID. So if you know the plugin ID by heart, you can see that you have a lot of this one. I don't know which plugin it is, to be frank. CV, again, you can quickly see that you have a cool CVs, at least five times in the data set. Here, CVSS, I don't care. Risk, high critical, the famous Nessus rating. Host, this is, you can see that this one has a lot of vulnerability, so this is a good target for your engagement. Protocol, okay. Port name, and here name, most common values, you can see more than 80 times you have this vulnerability. So, okay, this is quite interesting. Now, just filter, because you do have the column you want to filter on. Sorry. I will just use CSV stat. You can select the column you want, just to see what does it look like and to give you proper stuff. So what will it say? Here you can filter a bit, so you have only the expected column you want. And okay, this is a better view and not to be spammed on the terminal. Right now I'll be using another command, which is way more interesting than everything I showed you before. So I will be issuing a SQL query on my CSV Nessus output. I want the host the name from the report where the name looks like something you know. I guess. And I will just pipe it to CSV-look, which is just a fancy way to see a CSV file in a shell. It won't be as beautiful as you imagine here because the sentence from the name is way bigger than the terminal could handle, but on tiny, when you have small values, it's really awesome. So here it processes the query, and I hope we will have the answer. So really, I'm really writing a SQL query on a CSV, or plain flat CSV file. And here, so you can see, I have the host. I just wanted to filter for eternal blue stuff, and here I really have the list of hosts relevant to my search. Isn't that awesome? Just in a plain file? It changed my life. And here you have, so it's, again, every time the same IP, because it's, I don't know why, there's duplicates in that file. I just anonymized the IPs. This is true data, I just anonymized the IP on a large engagement. So this is it for CSV. The screenshot just in case the demo didn't work, I don't care. Then another tool that changed my life recently is Dataiku. Here in this room, ever heard the uses currently Dataiku? No one. Okay, perfect. Dataiku is a data science tool, nothing related to security, nothing related to Pentest or so on. And to be frank, in one word, it's Excel without the Excel limitations. To be clear, it is a web stuff. This is not free, but there's a free edition, but this is not open source. They do have a paid version and a professional license, but the free edition does everything you want and you ever dreamed of. So it is very intuitive. I will just show you after this. To be frank, it took me 4 hours on a 4-core plus 16 gig RAM machine to join the hash column of a 30 gigs uncompressed DB file, let's say Dropbox or LinkedIn or Dropbox leaks or whatever, with another file containing 4 gigs of hash column clear text password. And it only 4 hours. With your Hawk, sed, grep, whatever, you cannot reach this, and you cannot even do the same processing. So you would have to code something, I don't know, maybe input the data in a command database, I don't know. But with Dataiku, it's very simple. You just upload your CSV, you do some processing visually, even codes when you want to, and it does everything for you. There are some cool tutorials on their site just to comprehend the concept. So what does it look like? This is this. So first, you start. Where's my mouse? You have some projects. So here I have a Dropbox Leap project. This is not GDPR compliant at all. You can check GDPR on the bullshit bingo if you want to. For modern Pentest tricks, let's go back to the dataset I have. A dataset is a CSV file, to be frank, when you work with CSV. And here you can filter everything you want. So I just put a filter here on name. Let's say I want all the data related to this vulnerability. So it will filter graphically, and you can perform a lot of stuff with this. You can draw some charts. Let's try. I haven't tried this before. Yes, I tried before. So here I'm displaying the count of records associated with the vulnerability name. So the name according to Nessus. And here I do have some cool graphs. So for reporting, this is really awesome. I was using it for large engagement, and this is really, really cool. So you have cool graph here, a plain and stupid histogram, but you can have pies and whatever you want. This is awesome. Just from CSV and your common tool. What's the output of your common tool? I mean, so you can have a lot of information. Dataiku is really awesome. This is my last word on Dataiku. Try it, ready. Then parallel execution, another trick. I hope I'm not bullshitting you, but pentesting involves a lot of parallel work. You extract the result from a tool or from a process or from a phase. You launch a brute force on multiple targets, and you repeat every time. Being able to launch simultaneous stuff during your engagement is very important. Time is money, and time could be good security runs, and it could be an advantage for the red team compared to the blue team. So I don't like when my HTOP gives this. and that's why I'm using GNU Parallel. Who in this room ever heard or is using GNU Parallel? Oh, some hand, but not that much again. So GNU Parallel is a Perl script. Perl, but it's really awesome. To parallelize any command you want in your shell, it's a drop-in replacement of Xargs. I'm sure you know Xargs, but it's on steroids, to be frank. There's a lot more option than Xargs. So first you have a progress bar, the two first. You have a job log to have a track of what you're being executing. A resume to be able to resume where you left. This is cool stuff, really. That's every time it's missing when you perform some stuff, some brute force or whatever you want to stop. You have to stop, and you want to start over from the point you ended. And then you also have the ECSH login when you want to distribute the task on remote computers. This is awesome again. GNU Parallel, and most of the time, when I'm doing some stuff, some penetration test, my HTOP looks more like this, and I'm happy, really, because my machine really is not paid, and I'm not burning some energy just to do nothing and to have idle stuff. So use GNU Parallel as much as possible. A quick example here, I'm combining Parallel and WFuzz for when you have to enumerate URL on one server, one website. Yeah, you can use Airbuster, GRB, and so on. But when you want, how would you do when you have to perform a URL brute force or hundreds, thousands of sites simultaneously? Just use Parallel. So here you give your target list with your correct protocol and correct scheme here, port and whatever. Job log, progress, bar, just for visual fanciness, and this is really awesome. A wfuzz command. Here I'm automating a lot of stuff. Here this is my input. I cannot write here in this output. I cannot write any bad chars in the file names, at least on Unix. So I'm giving a sed/Perl expression to remove on the fly bad characters. I filter on the code I want. This kind of option just say recursive for 3 level deep. I don't even remember ZHC. I'm using every time this. I'm giving my word list, and here I'm saying I'm replacing this entry with 1, and here fuzz for wfuzz. And then when I want to automate really everything, when it ends, I just can parallel cat gq sed some stuff to have by filtering on the 200 code, even if I filter for way more code before. Here I'm just filtering for the 200 because I just want to quickly perform responding screenshot of responding URL with web screenshot. Here, this file is ready to be used by web screenshot, which is a tool I used and I developed to take quickly and efficiently screenshots of URL. So here, by combining everything, really you're outputting and you're throwing most of your repetitive and cumbersome work to almost a robot. Then another example for DNS enumeration. So you can compare. We will compare dig plus Parallel to another solution just after. But here you can also perform an enumeration for domains with Parallel, giving some subdomains. Yeah, which with a random, not a random, but my subdomain.txt file looks like this, and I have this number of entries. I'm performing a dig null non-answer just to have a tiny view. I could remove progress bar because it spams the shell. And really, how this method, this apparently cheap method, compared against a proper and optimized tool. So yesterday I tried with GoBuster. GoBuster is a software written in Go for DNS and URL enumeration. So written in Go means performance, native compilation. So you expect more performance and high performance from a Go program with multi-thread and so. So how did it compare with just a simple Parallel and dig stuff? By enumerating these entries for google.com on the hotel extra Wi-Fi, it takes me 22 seconds. And with Parallel plus dig, it takes me 27 seconds. That's 20% more, but even it's not that it's not that painful, because most of the time when you're on a target, you don't you don't have your tool on it, and you can only install some parallel or dig. This is a cheap but effective way, and to be frank, there's not much overhead for this method. So if you compare for this is not bad. This is my conclusion for this slide. So parallel plus whatever you want does a good job and is really performant. Then third trick, sometimes you have to reverse some custom what the fuck obfuscation or encryption scheme design in whatever application you are auditing. This is especially true for Android and Java. I don't like Java. Yes, this is lame, low, and slow. No, I'm kidding. It affects any technology. People do not understand crypto, so you can be able to reverse any custom what the fuck stuff in any language you can find. But still, this is really useful and really often encountered during Android application engagements. Sometimes you don't want to go down the rabbit hole to figure out how it works. Sometimes you don't have the time. You cannot replicate what you see inside a custom what the fuck encryption to your preferred language for static analysis, for example. For example, Oracle WebLogic Server encrypts local password with a specific schemes, which at the time and still currently, there's no Python module, there's no Python library, no Python crypto module supporting this, because Oracle WebLogic Server uses Bouncy Castle in Java, having at that time this scheme implemented in Bouncy Castle, but you don't have the similar stuff for Python. So you really need to use a high-level scripting language using off the land. Living off the land is a popular expression right now, but you have to live off the land and to use to stick to the original and native code, native application. So when you do some Android and Java application engagements, use Jython. Who in this room knows Jython? Oh, cool. Way more hand raised. So what is Jython for the other? Jython is something you write with Java code, which uses Java classes, but with Python library and Python syntax. Isn't that awesome? You can write Java stuff because you have to, because the world uses Java, but you don't like Java and you like to write Python simple code. And with Jython, it is possible to mix and to make the both hands meet. For dynamic analysis of everything else, use Frida. Who in this room knows Frida? Oh, again, quite good. So Frida is even better. You write Python, JS, QML, Swift, or .NET code, injecting C++ code in a JS engine to instrument assembly, Objective-C or Dalvik on Windows, Mac, Linux, Android, and iOS. So for dynamic stuff, this is the thing and the state-of-the-art tool to use. As a quick example, on the left you have a common Java crypto implementation that you can find in Android application or Java C client stuff or Java server-side stuff. So you recognize the word IV parameter spec, secret key spec, cipher, init, do final. This is the Java way to perform some encryption. If you want to perform it the same way in another language, it won't look like this, and you have different library, different way, different words to use. But in Jython, so with Python syntax, Python code, and Python code using Java classes, this looks like really the same. It's really easier to write. So you have here, you recognize IV parameter spec, secret spec, get instance, I need do final, without all the Java bullshit, you know, the new stuff, the get bytes, the multiple semicolon, I don't know. You don't have anything. Just take the Java code, clean everything, and you have your Jython code. As a real life example, so I implemented the Jython decryptor for WebLogic, as I told you just before, again on my GitHub. I can perform a quick demo, just not again to see that I'm not bullshitting you, not that much. Here, I have a tiny Jython script, so doing like a common Java encryption stuff. So I'm importing Java crypto, import everything. You know, all the Java. This is the Java library. This is not Python stuff. I can write here another line, importing some Python stuff. It will work. A Python library, and you can mix. You can mix both. This is the true awesomeness of Jython. Here you have the IV key, S key. I just want to decrypt here something. I want to encrypt. Sorry, I want to encrypt YOLOSWAG with a key in AES with a PKCS 5 padding, which is pretty common. But I could use any crypto stuff from Java here instead, and I'm just printing and displaying it in Python 2. Sorry, Python 3 guys. I like you, but this script is Python 2. Here, without the Java bullshit, you can encode hex. You do have some two-string stuff. This is some reminiscence from the Java stuff in Jython, but that's not that much to pay to use it. So let's just execute that script. You know, are you convinced that this script is pretty easy to write, pretty simple, and there's no tricks and no much caveat and no much trap to fall into? And if I just execute it, to be frank, it should work. So this is compiling your script in Java bytecode. You don't see it, and it executes it. So here, I'm just executing like a Python script, a Python style script using Java classes with Java crypto and Java methods. Is that okay for you? Is that clear? Are you convinced this is good? Again, Jython changed. Again, my laugh during last engagements. No, this is not this. Last trick, but not least. The last one is being able to compile Python script on the fly. So most of the time in real life engagements, you need to have a compiled version of a tool. Why? Because the target you're onto doesn't have the proper execution environment. You cannot set up it. You're too lazy. You don't have internet access. You're on no route. Any reason. You just need a fucking program to be compiled and just to execute on a single target that doesn't require any specific privileges. You don't have any proper reverse shell or interpreter, and you need to evade antivirus. So compiling on the fly for yourself the tools maybe could evade and could bypass antivirus. So compile Python script with PyInstaller, who uses heard PyInstaller just before some ends, not that much, but some. So what is PyInstaller? PyInstaller bundles a Python script, everything you want, with a Python interpreter in one executable if you want to, but it merges everything and it gives you a native build. To install it on Windows, you can compile everything on everything. This is again the same, but on Windows, first install one Visual C++ compiler. If you have Visual Studio on your Windows laptop, you already have this dependency need, and then pip install PyInstaller, nothing else. And you can even cross-compile. So imagine, here, with this method, you compile on Windows, you compile a Python script on Windows for Windows target. But you can, some French guy even tried, I never tried before, but I think it works. It really works for at least simple script. You can even cross-compile. So let's say you want to compile a Python script from your Linux to a Windows target. You can do it with Wine. Wine plus PyInstaller. This is awesome again. The most useful option of PyInstaller is one file. So you have really one standalone file. Everything is packed inside one executable. This is great. One dir is useful when one executable is way too big. By way too big, I mean more than 15, 16 megs, because it takes a lot of time to unpack. Because one file, what is one file? One file is a self-extracting zip payload. So if you have a lot of resources, it can take time really to execute. You have one interesting key for antivirus bypass is key. By default, there's no encryption for the standalone executable file. With key, you can provide a specific key, and it will encrypt the payload, but the key is inside the executable. There's no obfuscation, and so it just gives you an obfuscated version and encrypted version of your executable, and you can easily bypass antivirus with this. Really, an icon when you want a specific icon for visual fanciness. Really, the command to input is ready. You'll see just after. I think the demo is after. Okay, I will just show you the complete command. This is really really simple. So right now, if I want to convince you, I have to show you some real life example of Python script compiled in native executable, mostly for Windows, for most of the tool I will show you. Do you know Impacket? Do you know Impacket examples? Who in this room or Usually uses in packet example WMI exec, PS exec.python, and so. These are really cool stuff, mostly used during red team or Windows engagement, Windows pen testing. So here you compile all this awesome utility inside one executable that can perform. Here you can see WMI exec.exe. You can provide the hashes, and so it's getting a big popularity right now. So again, I compiled the version. Most of these tools are right now flagged by antivirus, but if you remember the key tricks, just take the Python file, specify your own key, and it will bypass antivirus. In the in-packet example tool suite, you have all of this utility. The most famous one you can find is mimikatz.exe, ntlm relay.exe, psexec.exe, samrdump just to dump some database, some hive remotely, secrets dump to process an NTDS file. So this is a real life trick that I use a lot of time, every time. When you cannot grab the NTDS database from a domain because of the network connection, because you don't have space on your own computer, it happens a lot. Just take that executable and put it on the domain controller on wherever you want, and you will be able to process the NTDL file, remotely, offshore. Just offshore the extraction, just grab the tiny log, the tiny hashes, and it way less spaces than grabbing the whole NTDS file. SMB exec to execute some stuff over SMB. SMB relay, ticketer to create in 2 arguments, 2 options, golden and silver tickets. WMI exec, which is way stealthier than SMB exec. WMI persist, WMI query, and in one executable each time. This is really awesome. Again, then do you know Patator? Patator is a multi-purpose brute forcer. You can see here how many protocol and stuff you can brute force inside one tool. So again, this is a Python script. I compiled it for Windows, and the challenge here, I was really hoping for the worst. The best came. So it depends on a lot of third-party modules, because when you need some libraries to brute force FTP, SSH, SMTP, AGP, Oracle, and so on. So you depend on a lot of third-party modules, which these dependencies have their own dependencies. So at the end, you have all this dependency, and you don't think that everything will be packed neatly into one executable. And guess what? pinstaller managed to put everything inside one executable. So basically, with patator.exe on my GitHub, you can brute force all this protocol with only one executable, one standalone file, which is, as I said, a bit big for the pinstaller paradigm. It's like 18 megs, and it takes, like on my crappy laptop, it can take like 1 minute between launching the command and having it properly executing the things you want. So the one dir option can be useful if you want not one executable, but one directory, but that you can move the same on the targets, and it will be faster. But so everything is packed inside that great utility. Again, crackmap exec. I don't know if I can officially say this, but I'm the unofficial official maintainer of the version 2 compiled version, which is way old and way older than the current one, which is version 3 with a lot of modules option, but still my version is UTF-8 compatible. So when you're not an American guy, with this you can pentest French companies and other countries where you can have some accent and some UTF-8 needs. So it compiles, and it's pretty used. To be frank, when I was doing preparing that presentation, I made some research, and I found a report from the British National Security Agency reporting that this tool, my tool, has been used in real-life attack on industrial system. I don't know if I'm proud of it, but I think it should convince you that it works in real life, this compilation. I'm not that proud, but I found that it was really used in a real-life attack. Then you have, again, another example, GDWP Cheliffer for the Java debug wire protocol. Again, in one binary stuff, this is pretty awesome. So some demos. So I won't compile this because it's already compiled. So I will just show you, again, a real life example. Few weeks ago, I was looking for a way to easily have some tunnels, dynamic tunnels without SSH, and I found a cool tool named rpivot, named by someone very famous whose nickname is Artcorn, something like this, pretty famous, and doing really the job with a simple two utility, server.python and client.python. You have dynamic tunnel end-to-end. You just need Python on the target and on your machine. On your machine, that won't be a problem. On the target, that shouldn't be a problem if you're attacking Linux stuff. But if you're attacking a Windows stuff, few chances, sorry, that there's a Python version, Python interpreter installed. So in that case, I wanted and I needed a single executable having that cool and awesome program allowing me to have some tunnels. So what did I do? pinstaller clean, just to clean some cache, one file. Server.python. It will compile, hopefully. It will compile this time. It will compile just for the. I'm showing you the Linux from Linux to Linux, but it works exactly the same on Windows to Windows. I just don't have the Visual C++ installer installed on my machine. Maybe I have. I don't even remember, but I'm using just Linux just to show you this. And at the end, you will see a proper and real native binary executable. So apparently, it compiled successfully. I can show you. Let me clear a bit. It is in the dist folder, server. So you can see that it looks like a native binary. And when you execute it, it should work. This is the same version. Just let me show you. Then the Python version. This is exactly the same, but this time you have it compiled in one executable. So if you want to drop it on a remote target, it works. And you don't need any environment for this. So there's maybe a last trick I wanted to show you. I haven't documented it, but in the next version of my talk, you can already dig. It's something. The next trick I would like to formalize is stop using grep. Grep is dead. Just use another alternative when you are doing some code search. There are some cool tools. There are multiple tools achieving and trying to solve the code searching, the pattern searching stuff inside code, structural code. You have different utility native tools which are named Sift. You have Sift, RipGrip, and the Silver Searcher. Those three tools are really awesome, and you have better performances and way more options than grep. For instance, something really used by the developer is if you want to ignore and to honor the git ignore file. If you are looking and searching through codes, you have some reason just to avoid some specific files that you document in your git ignore. And with this, you can honor and take into account the git ignore file. Something with grep. Grep is not meant for this. Grep is older than Git, and there haven't been any improvement just to honor this. This is just a tiny example, but really you have better performances. And I don't remember it right now, but either it's Sift, RipGrep, or the Silver Searcher. One of these three utility is the utility you can have in Visual Studio when you perform a search function. This is to show you that this is really used and really useful for code searching. Let's go back to the presentation. So with all these tricks, my final message is CSV kit all the things, data equal the things, GNU parallel all the things, JITAN all the things, Frida all the things, and pinstall everything. Thank you.
Okay, are there any questions?
Everything was clear to you? Are you pretty happy to know, and will you apply these techniques in your work, in your day-to-day job? I hope yes.
Okay, it doesn't look like it, so let's thank the speaker again.
Thank you.